In this class, we're going to go over questions on inventory model. Okay. John's farm has a total demand of 4,000 liters of herbicide per annum. The acquisition or ordering cost of order is 900 naira. If the price of herbicide is 80 naira per liter and the carrying or holding cost is 90 kobo per liter per month, find the following: the optimum quantity to be ordered at the time, the optimum period for which the farm should hold inventory, the optimum numbers of orders the farm should place in a year, and the optimum total inventory cost for the year. Okay, this is one of the models that we have in economics, you understand? And we've discussed linear programming model, game theory model, we have discussed replacement model. Now, here is another question on inventory model. Okay, so I want you to pay attention. Okay, let's start by writing out the information that you are given in the question. We are given that John's farm has a total demand of 4,000 liters of herbicide per annum. So the first information is that we are given the total demand. The total demand of herbicide per annum, total demand is equals to 4,000. Okay. Now, the acquisition or ordering cost is 900 naira. Ordering cost is equals to 900 naira. Okay. Now, if the price of herbicide is 80 naira per liter, the price per liter of the herbicide is 80 naira. Okay. Now, and the carrying or holding cost, holding cost is 90 kobo per liter. Holding cost is 90 kobo. Okay. Now we are given the 90 kobo. The holding cost is 90 kobo. Now we are asked to calculate optimum time to be ordered. Optimum quantity to be ordered at the time. Okay. So please, I want to pay attention. I'm going to represent these parameters that are given by some values. You understand? So let me just use letter. Okay. I'm going to call the total demand Q. You understand? Q asterisk. Okay. Let's call it Q. Or what should we call it? Yeah, let's call it D. Okay. Let's call it D. Let's call the ordering cost. We're going to call the ordering cost or the acquisition cost F. You understand? Let's call this one F. Then the price per liter, we're going to call it the price of herbicide per liter. That is 90 kobo, right? So we are going to call it C. Okay. Let's call it C. And the holding cost, which is 90 kobo. The holding cost, which is 90 kobo, that is, let's call it KC. Okay. KC. Now, and if you look at the question, the time is annum, and annum means a year. You understand? So the time is 1 year. So we can just represent that as time is 1 year, and 1 year is equivalent to 12 months. Okay. So we're going to call that one T. Okay. Let's call it T. Let me call it small t. Now, with respect to the parameter that we are given, we can proceed to calculate the optimum, that's the first question, the optimum quantity to be ordered at a time. We are going to use this formula to determine the optimum quantity to be ordered at a time. Q, the optimum quantity to be ordered at a time, Q asterisk is equals to, please pay attention, the square root of 2 multiplied by ordering cost multiplied by 2 multiplied by ordering cost multiplied by total demand, which is D, all over, are you paying attention, all over KC, holding cost multiplied by time. You understand? And the time that we're given in the question is 12. Do you understand? if you use this formula, you're going to get the optimum quantity to be ordered at a time. You understand? So now all you have to do is that you just have to substitute the information that you have into this formula. So the optimum quantity is equals to the square root of 2 multiplied by f. 2 multiplied by f. F is ordinary cost, which is 900. Are you paying attention? F multiplied by D. D is 4,000 all over KC. Now, pay attention here. You know that the KC is the holding cost, and the holding cost we are given is what? Is 90 kobo. We cannot use it directly. You understand? Because it is in kobo, we have to convert it to naira. You understand? Are you paying attention? So, if you want to convert 90 kobo to naira, how will you do that? Don't forget that 100 kobo is equals to 1 naira. Okay? 100 kobo is equals to 1 naira. So 90 kobo will be equals to x. So take the cross product. X is equals to 1 naira multiplied by 100 kobo all over 90. No, 1 naira. Sorry. X will be, if you take the cross product, x will be equals to 90 kobo. 90 kobo multiplied by 1 naira all over 100 kobo. Okay, so divided by this, you're going to have x is equals to 0.90 naira. Okay, because this kobo we have cancelled the kobo that is attached to M90. Okay, so I'm going to have here 0.90 multiplied by t is 12. Please, do you understand how I got this? If you didn't understand, listen to the explanation again. To determine the optimum demand that optimum quantity that can be ordered at a time, we use this formula, and I've already explained all the parameters that you have in this formula. You understand? So here I substitute all the parameters. Then while substituting, I discover that the holding cost is in kobo, and all the other values are in naira. So this will contradict this. In an attempt to do that, I convert that 90 kobo to naira. You understand? So that's why I have this. 100 kobo will equals to 1 naira. 90 kobo will be equals to x. If you take the cross product, x will be equals to 90 kobo multiplied by 1 naira divided by 100 kobo. So that's why I have 0.90 naira. Okay? So now let's proceed. Q asterisk is equals to, now take the square root of 2 multiplied by 900 multiplied by 400 multiplied by 4,000. This is 4,000. Okay? 2 multiplied by 900 multiplied by 4,000. That will give us 7,200,000. 7,200,000. Okay, 7,200,000 all over 0.90 multiplied by 12. That is 10.8. So here I'm going to have 10.8. So from this point, Q, the optimum quantity to be ordered at the time, is equals to the square root of, okay, let's divide 7,200,000 divided by 10.8. That will give us what? We're going to have 6 point, okay, let me put the square root. That is 66666.6667. Okay, so here I'm going to have Q asterisk is equals to, now the square root of this will give us 816.49 816.4965 816.4965. So optimal quantity to be ordered at the time is 816. I approximate. Now we are done with the first question. Okay, now let's proceed to the second question. The second question says we should determine the optimum period for which the farm should hold inventory. You understand? So now we are dealing with time. So the optimum period, I'm going to represent it as T. Okay. Now to get the optimum period for which the farm should hold inventory, you just have to make use of this formula. The product of T, okay, let me represent as T. The optimum period is equals to T multiplied by Q star all over D. Just make use of this formula. See, the T that we have here is the time. You understand that we are given in the question. And we are given that 1 year. And 1 year is equivalent to what? 12 months. Do you understand? So, by substituting the value, we are going to have the optimum period is equals to T, which is 12, multiplied by Q star. Now, Q asterisk is what? Is 816. Let me check. Yes, 816.41 or 4965. So I'm going to have 12 multiplied by 816.4965 all over D. D is what? Yeah, total demand is D, so all over 4,000. Okay, so here I'm going to have 12 multiplied by this. That is 9,797. 9,797.958 all over 4,000. Okay, so the optimum period that the firm should hold inventory is 2.449. So if you want to approximate, you're going to have approximately 2 months. Okay, 2 months. Now, so we are done with the second question. So if you are given this question in the exam, you just have to, number one, write out the parameters. Having done that, remember the formula. Okay, so by doing that, you'll be able to solve the question. This is just a bonus question. Now, let's look at the third question. The third question says we should determine the optimum numbers of orders the firm should place in a year. Optimum numbers of orders the firm should place in a year. To get that values, you just have to make use of this formula. The total demand divided by Q, the optimum quantity to be ordered optimum quantity to be ordered at a time. You understand? The total demand. Listen. If you want to get the optimum quantity, optimum numbers of orders per year, just divide the total demand. Okay, let me write out the formula. Optimum numbers of quantity. Let me represent as N. Optimum numbers of quantity that the firm should order per year. That will be total demand, which is D, all over the optimum quantity that the optimum quantity will be ordered at a time. You understand? See, this N is the numbers of orders that the firm can place by year. And if you want to get the numbers of orders that the firm can place by year, you're going to make use of this formula. And that's why I'm writing D all over the optimum quantity that can be ordered at a time. And the optimum quantity that can be ordered at a time is what? 816 points. So here I'm going to have N is equals to 4,000 all over. Optimum quantity that can be ordered at a time is 816.4965. So 4,000 divided by 816.4965. That is 4.8989. 4.8989. Okay. So the optimum quantity that can be ordered at a time is equals to 5. Approximately is equals to 5. But you can leave it in decimal place. Okay. Now, so we are done with the third question. So you can see that remembering the formula alone will ease the problem. You understand? So if you I beseech you, just make sure you master the formula. Okay. Now let's proceed to the fourth question. We are asked to calculate the optimum total inventory cost for the year. Now, to get the optimum total inventory cost for the year, you just have to make use of this formula. Total cost is equals to CD. Please pay attention. CD plus FD all over Q. Okay, let me write it here. The total cost, let me just put the total cost. CD plus FD all over Q star plus KCTQ all over 2. You understand? Let me put this star. If you remember this formula, you'll be able to solve for the total cost, the optimum total inventory cost of the year. You understand? So Just pay attention. Now, don't forget that C is what? C is the price, you understand? The purchase price per liter, and that is what? 18 naira. So here I'm going to have TC, the optimum. Just put asterisk, you understand? So as to signify the optimum. So using this formula, you'll be able to get the optimum total inventory cost for the year. Now, don't forget that C is what? C is 18 naira. So I'm going to have the optimum total inventory cost of the year. That will be C. C is 80. So I'm going to have 80 multiplied by 4,000 plus FD. F is what? 900 naira. So I'm going to have 900 multiplied by 4,000 all over the optimum order that can be placed at a time. That is 816.4965. 816.4965. Okay, plus now we have the holding cost, which is 0.90 multiplied by T. The time that we're given is 12. So I'm going to have multiplied by 12 multiplied by Q asterisk. That is the optimum demand. That is 816.4965. 816.4965. Don't mind. I'm just trying to manage the space. You understand? Divided by 2. Okay. So with this, you can get the value of TC. Just pay attention. TC is equals to, now let's proceed. Let's first take the product of all the values that we have there. 80 multiplied by 4,000. That is 320,000. You understand? So I'm going to have 320,000. Okay, plus 900 multiplied by 4,000. That is 3 million 600,000. Okay, all over 816.4965. Okay, plus 0.9 multiplied by 12 multiplied by 816.4965. What you have here is 816.4965. You understand? So don't get confused. Okay, so 0.9 multiplied by 12 multiplied by 816.4965. That is 8,818.1622 divided by 2. Okay, so here we are going to have TC is equals to 320,000 plus, now let's divide 3,600,000 divided by 816.4965. That is 4,409. 4,409.0819 plus, now 8,818.1622 divided by 2. That is 4,409.0811. You understand? So now if you add this together, we're going to have, sorry, this is not square, that is asterisk. If you add all this together, you're going to have 328,818.163. Okay, so if you approximate it, you're going to have 328,818. That is the optimum total cost of inventory. You understand? That is the optimum total cost of inventory. Optimum total inventory cost of the year. You understand? So you can see that the solution is simple. All you have to do is to remember the formula. Okay, so if you are going to come across, if you come across such question in the exam, you'll be able to solve it by number one, write out the parameters, you understand, then remember your formula. And if you are given the holding cost in kobo, make sure you convert it to naira. Okay, make sure, don't forget, make sure you convert this to naira. Don't use the kobo directly. Okay, so that your calculation will not be contradicted by, because we have the some cost in naira, so we have to convert to what, to kobo. I mean, you have to convert it from kobo to naira. That is if you are given in kobo. Okay, so that will be all for this class. If you have any question regarding what we learned in this class, let me know in the comment section. And before you go, don't forget to like and share the video. Okay, it's important. Don't forget to like and share the video, and you can also subscribe if you want to be part of the channel. But it is important that you like the video and share it. Okay, see you in the next class.